So as we said, we are studying about the solar system, and this is chapter 10, lesson 1. Okay, so first we talked about the axis, which is this imaginary line.
Okay.
Change my pointer. So this imaginary line going through the Earth or the center of the Earth, from the North Pole to the South Pole, as you can see. Okay, so as you can see, this line is not real. Again, it's imaginary line. Okay, and obviously it's not standing up straight, is it?
It's a little bit tilted.
Yes, a little bit tilted. Well done. Yes. So maybe some of the information you're going to hear about today, you already know them. Okay. So let's move to the next slide. Then we learned that there are two movements of the Earth. We have rotation, which when the Earth moves around itself, like the one on the left here. When the Earth moves around its axis, it's called rotation. We can say also it's the spinning of the Earth around its axis, or the movement of the Earth around itself, or the movement of the Earth around its axis. So you can say it in many words. So this movement takes 24 hours. So every day, the sun completes one rotate around its axis every day. And this movement causes day and night. Okay? The other movement as revolution is when the Earth revolves around the sun. So what we mean by revolution, it's when something, goes around something bigger. So when the Earth is moving around the sun, it's revolving around the sun. So that means it's doing another type of movement, which is revolution. And this takes 365 days, takes 1 year. So the Earth takes 1 year to complete one round around the sun. And this movement causes seasons. We'll know later why the rotation causes day and night and why revolution causes seasons, okay?
Okay.
Okay. So first we have the reason why the rotation causes day and night, because first the Earth keeps moving around its axis, so some part or half of the Earth will be facing the sun. That means they have daytime there. The other half will be facing away from the sun, which means that we have nighttime then.
Okay.
Okay, so let me show it to you in another presentation, I'm sorry.
Okay.
It's nice to see you, Hamza. Yeah, Willie miss you here in the school, and all your friends miss you too.
Miss, I'll mute my mic for a second.
You what?
I will mute my mic for a second. I'll just call my brother for something fast. I'll mute.
Okay, you can mute. It's okay.
Raising his voice because
It's okay.
he's talking on the phone.
It's okay. It's okay. It happens all the time. So we were just talking about how your friends misses you too. Your friends miss you a lot, by the way. I do miss you too, Hamza, in the class. And today I remember Omar saying that we were playing with the spinner, and to pick who will answer the question, stuff like that. And then Omar said, if Hamza's name comes on the screen, I will cry. And we all were touched, because we do miss you a lot. We'll hope everything will be okay and everything will come back to its senses. And
Inshallah, I will come in term 4.
Inshallah, bismillah. And I hope it will be a lot better then. Okay, so in here, you can see the screen.
Yes.
Okay, so I want you to look closely how the Earth will get some light. So first he's showing you the axis and that it's not standing up straight. And then he's going to show you that the Earth rotates every 24 hours. So one rotation takes 24 hours, okay?
Okay.
Which means 1 day. Now let's see how the sun will light a part. Can you see this? A face, there is a part of the Earth where it's getting all the sunlight, while the other face is actually darkness. So it's having nighttime.
Miss, your voice is cut.
Okay, can you hear me now?
Yes.
Okay, so maybe, yes, it's telling me that the internet connection is unstable. So anyway, you can see here that we're having two faces or two parts of the sun. One part or half part is facing the sun where there is daytime, while the other face or other part is facing the other words or the away from the sun, which means that it will have night time. Let's go back to this movement again so you can see it.
Miss, your voice.
Is my voice keeps cutting?
The mic keeps muting.
Muting. Why is that?
No.
Check. Let me check.
Miss, could I ask you something?
Yes?
Do we have a quiz Wednesday, right?
Yes, we're having a quiz on chapter 9, lesson 1 and chapter 9, lesson 2.
Chapter 9, lesson 1 and 2. The water cycle lessons?
Yes, and the one about precipitation.
After the meeting, I will go study these times because
Oh,
I was
okay.
supposed to study it yesterday.
It's okay. I will upload all the summaries also, inshallah, as soon as possible, okay? But you can check from your book. You can go watch the previous online sessions. And if you have any questions, you can just send it to me anytime, okay?
Okay.
Okay. So again, as you've seen the movement of the Earth, this is why rotation causes day and night,
Night.
okay? Yes, because one half will be facing the sun, having daytime, while the other half will be facing away. Now let's look at revolution, which means one round of the Earth or one orbit that the Earth takes around the sun. And this movement takes 365 days, which means almost a year. Okay? Can you see that? So it's 1 year to just finish this movement. And because the Earth is not standing up straight, as you can see, it's a little bit tilted. That's why we also have different seasons.
Okay.
So let me show you in here. Just let's get back a little bit. Okay, so as you can see here, he's showing you that the Earth has two halves or two hemispheres. We have northern hemisphere and southern hemisphere, and we have the equator in the middle, as you can see that.
Okay.
Okay, so the Earth again is not standing up straight, which causes the difference in the seasons. And here you will see
Miss, your
that
voice is muted.
again.
Yes. Now I can hear you.
Okay. So maybe it's just the Zoom itself. It's just sometimes makes stupid things. So don't worry about this, okay? Anyway, I'm recording the session and I will upload it. So you can watch it anytime you want if you didn't hear me in some parts, okay?
Okay.
Okay. So as you can see here, that the upper half, which is the northern hemisphere, is having winter because it's tilted away from the sun, while the southern hemisphere is tilted toward the sun, so it's kind of closer to the sun, so it has more heat, and that's why you can see that it's having summer. Let's see it from another perspective. So let's get back here, talking about seasons. And here he says that the part of the earth tilted toward the sun gets more heat, which means they will have summer. While the part of the earth tilted away from the sun gets less heat. So winter, summer, it's getting less heat. What do you think?
Let's hate it's winter.
Yes, winter. So here he's showing you what we're talking about. So let me zoom in. Can you see this?
Yes.
Yeah, so we're having the Earth again with the equator in the middle. That's giving the Earth two halves, the northern and the southern hemisphere. So as you can see, the Earth is tilted, making the northern hemisphere or the upper part tilted away, while the lower part is tilted toward the sun. Can you see that?
Yes.
Yeah, so it's getting more heat now. While the upper part is getting less heat, so the northern hemisphere will face winter or summer?
Winter.
Winter, well done. And the southern hemisphere will be facing the opposite.
Summer.
Yes, the opposite season, which will be summer because it's tilted toward the sun. Let's move to the summer. Can you see it?
Yes.
Yes, and here we have also the Earth, northern hemisphere, southern hemisphere, but this time the Earth is actually tilted toward the sun, or the northern hemisphere is tilted toward the sun, so it's getting more heat. That's why it's facing summer. What about southern hemisphere, the lower
It's
part?
facing winter.
It's facing winter. But in the middle between winter and summer, we have in parts where the Earth is in a position where neither is tilted, neither parts or neither hemispheres are tilted. Yeah, neither the hemisphere, the northern, I'm sorry, and the southern are actually tilted toward the sun. So they kind of get the same heat. So in this case, they're having spring or fall or what we call autumn. Okay.
Okay.
So in here is showing you what if the Earth, let me show it to you again. It's showing you what if the Earth is not tilted, what will happen. So let's go back again. So in here, the Earth, as you can see, is not tilted. Okay. This is what if the Earth was not tilted. So the Earth here is standing up straight. So the sun is only heating the equator. Can you see that?
Yeah.
It's not moving in different or heating different places. So that's why if we didn't have the Earth's tiltation, or if the Earth was not tilted, we would have the same season the whole year round. Do you get it?
Yes.
Yes. So let's see how now when it's tilted, it has more of different or uneven heating.
If it's not tilted, on the northern hemisphere will have summer, and the southern will have winter all the year, and
We'll
it
have,
doesn't
yes, all
change.
year round, the same season all year round. And here is also showing you that how the northern hemisphere, the upper part in here, because the red here is the equator, the upper part is actually having more heat because it's tilted toward the sun more than the southern part, because now it's having less heat. Can you see? So that's why the
Yes.
tiltation is very important. And because of this, we have different hours of daytime and nighttime. I mean, sometimes we have longer day hours or longer night hours, sometimes.
Okay.
Yes, and that's a new term. Just give me a minute. Give me a minute. Just give me a minute, okay?
Okay.
Okay, so this term is new for you. We have something called winter solstice and summer solstice. And in winter solstice, it means that the hours the
Or is
hours
longer.
of the night are longer. Yes. Okay, and the winter officially starts in December 21st. This is when winter solstice starts too. So when I say winter solstice, it means that night hours are longer, okay? While the summer solstice, it's officially starts in June 21st, and it's where the day hours is longer,
Oh,
and that's why it's way hotter in summer because we have more heat. We're receiving more heat now. And in addition to being tilted toward the sun, but now we're having more heat because the day is longer. We're having more daylight.
okay.
And between those, we have time where the hours of day, light, and darkness are equal. And this
Autumn and
is,
spring
yes,
have the same day and hour.
well
Have the
done. Yes,
same
day and night.
night.
Yes, the same hours of day and night, and that's where we call it equal. So we have equinox, like equal, equinox, equal, equinox. Okay. So we have autumn equinox and spring equinox. Autumn officially starts September 21st, and spring equinox starts March 21. So yes, this March 21st will be officially the beginning of spring. Okay.
Okay.
So we have solstice along with winter and summer, and we have equinox along with autumn and spring. Any questions till now?
No.
Okay, so let's start with these questions. Can you answer them?
Okay. When the
Okay.
northern hemisphere is tilted
Away
toward
or
the,
toward the sun, it's summer.
I'll have to move this because I could see. I can see. Tilted toward the sun, it's summer. Toward.
Yes, well done. It's toward. Well done. So let's pick the other one, number two.
When nature hemisphere is tilted toward or away from the sun, it's autumn or spring.
Yes, well done. Thank you so much. Now,
When the
number
northern
three,
when the northern hemisphere is tilted away from the sun, it's winter.
it's winter. Yes. Now, number
During
four. Oh, I
during
just
all this
answered it. I'm so sorry
during
about this.
during all
Yes,
this
but you can
time, the
read the
southern
sentence.
hemis During all this time, the southern hemisphere experienced the opposite, same or opposite seasons.
Yes, so it's going to be opposite season. So if the northern is having winter, southern will have the opposite season, which is summer. If it's having spring, the northern hemisphere is having spring. That means summer will have the opposite season, which is autumn. This is what he means by that. Okay.
Okay.
What are the two ways in which Earth moves?
Rotation and revolution.
Yes, well done. Rotation and revolution. And then we talked a little bit about telescopes. Okay. Telescopes. This is a nice word. It actually means seeing far things or far objects. This is what we mean by telescope. Okay.
Okay.
So telescopes are amazing because they make things look larger. So you think that they are closer. So we have two types of telescopes. We have refracting telescope, this huge big one that was kind of one of the first telescopes used. And it was used by this amazing scientist, Galileo Galilei, who actually said that the Earth is not the center of the Earth. I'm sorry, the Earth is not the center of the solar system. The sun is the center of the solar system. And he said that the Earth is not flat, it's actually a sphere. So he had a lot of amazing theories, and he was one of the first people that used the refracting telescope to see the moon. So he can see the moon, okay? He
Okay.
saw the moon with it, yes. So why do we call it refracting? Because they use lens inside of it. A lens that makes the moon looks larger, so you can feel it closer to you, so you can see most of its details. And this is how it looked like. Can you see how big it was?
Yes.
Yes, and this is, of course, Galileo Galilei, as we said. In
I
here we
heard
have,
that the people killed Galileo Galilei.
yes, I told you guys in the session, they killed him. They
Yes,
executed
I
him because,
remember.
yeah, they thought he was maybe having some magic things going on. Okay, then we talked about the reflecting telescope. So we're having a quick revision. And he invented another telescope is called reflecting. And we call it reflecting because it reflects the image of the moon on mirrors. And these mirrors make the objects also big, looks or seems bigger. And that's why you feel they are smaller. So again, we have two types of telescope, refracting telescope and reflecting telescope. Okay.
Okay.
Now let's move to where we're supposed to start our session today. We're talking about Earth's moon. Okay? So, as the Earth orbits the sun, moon orbits the Earth. Obviously, right? So moon
Yeah.
orbits the Earth and Earth orbits the sun. They're so connected. First, we're talking about the moon's surface, and it is rocky. People can stand over it. I mean, they can walk over the moon because it's made up of rocks, you know?
Okay.
Yes, like this astronaut walking up there. Number two, there is no liquid water on the moon.
Okay.
Can you imagine that? So if you decided to go to the moon one day, you should bring water with you.
But how will I drink it? Because I will be wearing the space suit, and I can
Yes,
take it off because I will
they
die if I do.
actually drink with a straw. You cannot assistant drink with a bottle like this because of the gravity and stuff like that. So they have a technique. You can go and check it. How do astronauts drink water and how do they wash their hair? One time I watched a video of a female astronaut washing her hair and how water keeps floating around her. You can see water just floating around because there's no gravity up there. And how it's hard actually for her to do that. But I mean, it's really nice. And also drinking and eating is not easy because they don't have gravity to pull the food down. So it's a little bit hard for them to swallow the food. So they need to eat and drink in specific ways. And if you're wearing a suit, I mean, you don't have to drink when you're wearing a suit, but you can take it off because there are some stations on the moon where people can sit inside,
Okay.
stay inside, okay? So you can drink and do stuff like that. But I think in the special techniques. Number two is that the Earth, for example, has an atmosphere that protects it from all the asteroids and all the rocks that are gonna hit us. So all these rocks they burn once they come closer to our atmosphere.
Okay.
Unfortunately, the moon doesn't have this protection. The moon has almost no atmosphere to protect it. And that's why you can see these craters over the moon, these holes. Can you see these holes?
Yes.
Yes, can you imagine how they were made?
Because of the asteroids, because the moon has no atmosphere,
Yes.
the asteroids hit it and it makes holes.
Yes, well done. That's right. So in here, we did this experiment in the class with your friends. So in here, she is trying to show you how asteroids are made. So once a rock hits the moon surface, it makes holes, which we call craters. And because again, the moon doesn't have any protection, he keeps, of course, keeps hitting all the time, hit it all the time. But also, there's something very important. If there is wind or water, they will take off all these craters. So how do we know that there is no wind or water over the moon? Because these craters stay
Because
there for years.
yes.
Yes, they stick there for years. Even the footprints of astronauts, the footprints are still there. Can you imagine that?
How many astronauts have been to the
I
moon?
really don't know the numbers, unfortunately, but I think
I
it's been
think
it's been a
three.
lot, because now you can go to the moon easy.
The first three were Commander Armstrong, and I don't remember the other.
Yes, he was the first man to step on the moon. His name was Neil Armstrong. Yes, he was American man. So again, even those can stay because there is no wind to move the sand away or change the shape of the moon's surface. These are the names of some craters. Can you see that they name the craters because they stay there all the time? They do not change place?
Miss, do we have to take all these names?
No, of course, no. I'm just showing it to you. No, you don't have to memorize names, of course. I don't know them.
Millions of names.
Yeah, that's a lot. And I believe that there are some names that they did not mention in this picture too. And here we have the moon's surface and the Earth's surface. You have a compression between them. So both of them have rocky surfaces because, on Earth we can walk on the Earth's surface. So we have rocky surface. But the difference
Yes.
here is that the moon's surface has no liquid water, while we do have liquid water on Earth because, Earth is a blue planet. It's covered with water, almost all of it. Moon's
Okay.
surface has almost no atmosphere, so it has no protection, so it has more craters, while Earth's surface has an atmosphere, which makes it less craters. Yes, we do have craters here on the Earth. We do.
Okay.
Some rocks were so big that they could penetrate the atmosphere and hit the surface of the Earth. Okay?
Okay.
Do you get the differences?
Yes.
Okay, so let's just walk through this a little bit faster. We have the moon. Of course, the moon is a small planet-like. It's almost as size as planets, and it revolves around Earth. Okay?
Okay.
Okay. So the moon has different shapes. We learned about them last year. We call them the moon phases, if you remember.
Okay.
They are the different shapes of the moon, and they take 29.5 days to complete one round around the Earth. So almost a month.
Okay.
So every month, the moon actually revolves around the Earth and changes its shape during this movement. So we have waxing. Waxing. Can you see
Waxings.
that? Yes. Can you read it?
The bright part gets bigger and bigger.
Yes, that's right. When the bright part is getting bigger and bigger, this is what we call waxing. So, for example, we're having waxing crescent is when we're having a crescent. How do I know it's waxing, not waning crescent? Because the bright side is on the left, the right. Can you see this? The
Yes.
right side is the one with light, so that means it's waxing. Because if you check the next phase, you will see that it's also the right side of the moon with light. Can you see that?
Yes.
So this is called first quarter, and you can see that the right part is the one with light. And here we have waxing gibbous, which comes after the first quarter. You also can see it's almost full moon, but you can see it's the right part or the right side is the one that has light on it. After waxing gibbous, we have, what do you think will be next?
Full moon.
Full moon, yes, big one, circle on the sky.
Miss, is the waxing when the right part is light has
Yes,
light?
that's what we mean. Yes. How
But
do
if
I
it's
know?
but
This
if
is
it the left side has the light and the right side doesn't, then it isn't working.
It
The
isn't waxing. Yes.
or
So
am I wrong?
yes, that's right. Because I mean, if you looked at this picture alone, how would I know this is a first quarter or last quarter?
I'm sorry, my Wi-Fi was bad.
It's okay. How do I know if this is a first quarter or last quarter?
First quarter is on the right.
Yes, so you have the light on the right. Yes. How do I know this is waxing crescent or waning? Because the light is always on the right
The right.
side. Okay? Yes.
But if it's a croissant on the left and the light is on the left side, it is a it is a
Waning,
one
yes.
croissant.
And that's what comes after the full moon. After the full moon, now the moon will go back to its previous shape. So all this bright light will get smaller and smaller. And that's what we mean by waning. It's when the bright part gets smaller and smaller, which means the moon is getting darker and darker. So we start with waning gibbous after full moon. Now we're having waning gibbous. Can you see that the bright part is now on the left?
Yes.
Yes, so that means it's waning. After waning gibbous, we'll have last or third quarter. You can see now that also the bright side is on the left. Can you see that?
Yeah.
Yes. And then we're having waning crescent, where the crescent is actually on the left. So now we know it's waning crescent. So now you can tell the difference when you look at the moon. Now
Okay.
you will be able to tell the difference. Last is actually the new moon, where you cannot find anything bright about the moon when it's dark, but you can
I can see a little light.
slightly see some light up there.
It's spaghetti.
This is also how the moon changes as it moves or evolves around the Earth. Can you see it?
Yeah.
Yes. It's really amazing, the moon thing. So special.
Okay.
So that's it today. Thank you for sticking around and listening. Do you have any questions about this? Do you have any questions about those?
No, I
Hamza?
don't.
Okay. I will send you at some links to play with. You can have them as games. You can send me the answer, okay?
Okay.
Okay. So are you sure you don't have any questions?
Yes.
Okay. This is the end. Let me send you the links now. Thank you so much,
Okay.
Hamza.